What's up, rock stars? Welcome to another video about math, and this episode is about, that's right, perfect squares. It's going to be a good time here in math land, so let's get rocking with some perfect squares. Before we do that, I know, what's the joke? What's the joke, big guy? Well, here you go. Why do hamburgers always taste better way up in outer space? Have you ever thought about that? Well, it's because they're meteor. Meteor? Come on, that was awesome! Let's rock. Meteor. I love it. Let's get rocking and rolling. Okay, today what we're going to talk about is perfect squares, all right? So what I'm hoping you will get out of this is that you're going to understand what do I mean when I say perfect square, or more importantly, what do other people or what does the world mean when they're thinking of perfect squares, and how do I represent it and recognize one? Okay, you'll also be able to justify if a number is a perfect square. Okay, that may sound a little confusing if you've never heard perfect square before, but let's see what that actually means. Okay, so first vocabulary word, perfect square. So this is a number made. So we make a perfect square by squaring a whole number. So if we look at the examples right there, we can see that 16 is a perfect square because, right here, 16 is a perfect square because the number 4, which is a whole number, if we square it, which means squaring something means putting it to the second power, which means 4 times 4 equals 16. So a perfect square is made when we take any whole number and we square it, such as 4. 4 times 4 is 16. Same thing with 25. 25 is a perfect square because 5 squared, which is 5 times 5, equals 25. So that's a perfect square. Okay, we're going to dive in a little bit to what it means to not be a perfect square shortly. All right, so we got another vocabulary word, standard form. Okay, and I just want you to understand this, and there's a couple other words at the bottom that we don't necessarily have as a vocab word in this video. You may see it later, but standard form is just basically means the general term that society uses or mathematicians use to say it's written down in the way most commonly accepted. When we look at numbers like 876, that's how we write it down, okay? There's another way that we use it in math. Sometimes we break it down by place value. So we know that the 8 means 800, the 7 means 70, and the 6 means 6. That's called expanded form. We're taking standard form and we're breaking it down by place value. And then written form is just what it sounds like. We actually use the words that are coming out of our mouth. 876. But the word that we're focused on right now, or the vocabulary word we're looking for, is standard form. All right, let's dive in a little bit here. So let's think about what I mean when I say perfect square. So here is a perfect square. This is 4. So it's literally, now you're looking at a square. And when we figure out if a square is perfect, we figure out what is the number that what is the whole number that we multiply together to get to the 4? Well, if you look at this picture, it kind of gives you the answer. We have 2 rows, 1 row, 2 rows. So that means going up and down, we are 2 high. And then we have 2 columns, 1, 2, which means going side to side, okay, we are 2 wide. So 2 times 2 equals 4. That's why that's a perfect square, okay? And we can continue that pattern. If we continue, we'll see, what is that going to be? That's 9. That's a perfect square because we used a whole number, which was 3. 3 times 3 gave us 9. You guessed it. 4 times 4 gives you 16, right? Because we're 4 high and 4 wide. We multiplied the same number by itself each time, okay? We go, what's the next one? That's right, 5 times 5, which gives us the perfect square of 25. Okay, and then the next one is 36, which would be 6 times 6. Okay, if we made this 6 by 7, we would go like this, and that would give us a number of, so this would no longer be, that would be 6. This would be 7 wide. That would give us 42. Now that's a whole number, but is this a square? No, we've turned it into a rectangle. So it has to be the same number on the side and the bottom. So it has to be same number high and same number wide to get to what you're trying to get to make it a perfect square. All right, so now that we know that, let's see if we can fill out this chart. Okay, so perfect square and square root kind of go hand in hand when we're doing math. So a perfect square is that number that we talked about. So if we do this again, we say we were 2 by 2, and that gave us the perfect square of 4, correct? So that would be, if this column had a 4 in it, the square root of it is, when you have the 4, you're asking yourself, someone says, what's the square root of this number? They're saying, what's the number that we multiplied by itself to get to that answer? So if 4 was up there, it would be 2 times 2, correct? It's not up there, but you can see 9, the perfect square was 9. What did we multiply by itself to get to 9? Well, we multiplied 3 times 3, right? So let's see if we can fill out the rest of the chart. Okay, let's start with this one. It gives us the perfect square, which means we have a square that is 7 by 7. Oh, shoot, I just gave you the answer. So you're going to give you that one for free. 49 is what's inside. What is it that's on each side? Well, 7 times 7 gives us 49. Now we're going to go the other direction. Okay, we're going to go the other direction. So what, if we know the square root of our perfect square is 11, what is our perfect square going to be? Well, we have a square, and we know that one side is 11 and the other side is 11. You're starting to see, if you haven't figured this out, that knowing your times tables is going to be a big part of this, or having a way of figuring out what your times tables are is going to be a big part of this, okay? So 11 times 11 is what, guys? If you have that memorized, you're going to be in a good place. If not, you're going to realize that's 120. Oops, that's 121. Okay, so this is going to be 121. We already said that was 7. Now they get harder. Okay, and it's going to be harder for us to figure these out because they're massive numbers. And again, like I'm trying to tell you, if you memorize these, you will like life a little bit better. So memorizing your perfect squares is like memorizing your times tables. It's just something that comes in handy and makes life a little easier. So what do we think the square root of this perfect square of 196? In other words, we have a perfect square that looks like this, but better than that. What is the square root? What's the number that we're multiplying by itself? Okay, now, if you don't have these memorized, let me give you a couple clues on how to make this life a little easier for yourself, okay? Let's switch over to pen, and let's look at the number that we're talking about, okay? So we're talking about 196, and it's, if you don't have this memorized, just look at the last number, okay? The last number is 6, okay? And then think of your easier times table problems and figure out which one of them ends in a 6 when we're multiplying whole numbers together. Well, if we take 2 times 2, it equals 4. 3 times 3 equals 9. 4 times 4 equals 16. Well, there we go. Now we got a 6, so that's a good sign. 5 times 5 is 25. 6 times 6 is 36. Oh, there's another one that it could be. Okay, and then we got 7 times 7 is 49. 8 times 8 is 64, and 9 times 9 is 81. Okay, so if we're looking at those, now we've just eliminated a bunch of answers because the only 2 answers that it can be are something that ends in a 4 or something that ends in a 6. Something that ends in a 4 or something that ends in a 6, okay? So we know that it's not 4 times 4 is 16 because we're trying to get to 196, right? So if it's not 4 times 4, maybe it's 14. Whoops, let me change colors here. Let's try maybe 14. And then the other one we could try, because we said 4 times 4 is 16 and 6 times 6 is 36. So we could try 16. Okay? Now, if we go ahead and try both of these, we will get to our answer. So let's go ahead and try the 14 times 14 first. What's 4 times 4? That's 16. I know a lot of you have different ways of doing 2-digit times 2-digit multiplication. I'm just going to do this one because this is the one that I use the most. If 4 times 1 is 4, plus that 1 that I just carried is 5. Put that 0 there. 1 times 4 is 4. 1 times 1 is 1. And if we add these up, 6 plus 0 is 6. 5 plus 4 is 9. And 196. And there we just figured out our answer. We didn't even have to do the 16 times 16. So 14 times 14 is 196. So that means that value is 14. All right, so let's go back and fill in everything. we have 7, we have 121, and we have 14. One more to go. Now we have a square that we're trying to solve. What we know that the square root of that square is 20, which means that's what the sides are. Anyone know what that answer is? Well, again, if you memorize these, it'll be easier, but this one's not that hard because it's a number that ends in 20. And if we're multiplying 20 times 20, that's going to equal 400, okay? I had a math teacher when I was young teach me a little trick with multiplying with numbers that end in a 0, like 20 or 500 or 7,000. And he told me that if you line them up a little differently, a little trick, let's see if you guys like it. If I take 20 and I multiply it, just put the 2 here and line it up like that. Go ahead and bring this 0 down. You don't have to do it this way. It's just a little trick I learned a long time ago. And then 2 times 0 is 0, and then 2 times 4 is 4. And that gets you your answer, so you don't have to do the double column. So that would be 400. Whoops, 400. Not too shabby, right? All right, one more. If we're thinking about perfect squares, so look at the pattern of increasing perfect squares, okay? And as we're doing that, increasing perfect squares. So we have 9, 16, 25, 36, 49, 64. What number is going to come next? Well, 9 would be 3 squared. 6 would be 4 squared. 25 would be 5 squared. 36 would be 6 squared, because all of these, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 squared, 7 times 7 is what? 49. 8 squared, 8 times 8 is what? 64. And then finally we get to 9 squared. So the pattern is it's going up by one whole number each time. And what is 9 squared? That's right. It's 81. Good job. So I think a couple things you'll learn as you're going through perfect squares and square roots. It's going to be really important that you have a way of finding out how to manipulate your times tables, because it's almost always going to come down to, do you understand multiplying your simple single digit whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, and 9? Do you have those memorized? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. If you have those memorized, it'll make life a lot easier. And then eventually you can get to the other side of it, which is multiplying the double digit up to 20 is kind of a good place to go. Not many people know 21 times 21, 22 times 22, 55 times 55. Those are massive numbers. All right. Hopefully you guys enjoyed this, and hopefully you learned something fantastic. I was thinking about astronomers, since we're thinking about going to space. And I'm wondering if you guys know, what is an astronomer's favorite key on the keyboard? This should be pretty simple, y'all, because it's the space bar. Cringy.com. I love it. Let's rock and roll.